All right, so here we go. On bell work today, we are finding vertical asymptotes and then using long division to simplify. So first thing we're going to do is find vertical asymptotes. Max, how do I find vertical asymptotes? Factor the bottom. So we're going to take the bottom, set it equal to 0, and we're going to solve. What did you factor that into, Max? Lydia, what did you factor that into? X minus 2 and x minus 1. So we're going to have vertical asymptotes at x is equal to 1 and 2. How could we quickly tell if those were holes instead of vertical asymptotes? We could plug them in. Holes happen when you get 0 over 0. So right now, we're assuming that we're getting a number over 0. If I plugged in 1 on top, oh yeah, I would not get 0. If I plugged in 2 on top, oh yeah, I wouldn't get 0. But if I were to get 0 over 0, it's because a factor is the same on top and bottom. Okay, but that is not happening here. Those are just vertical asymptotes, so we're good. Next thing we're doing is we are using long division to simplify. So to do long division here, we are putting x squared minus 3x plus 2 on the outside. And underneath, we're going 3x cubed. There's not any x squared terms, so I'm going to put a 0 there to just space it out. Plus 4x plus 11. We're doing long division, so let's remind ourselves how to do this. We look at this problem, Matthew, and we ask ourselves the question, x squared times what is going to get me 3x cubed? 3x. So he's going to put a 3x up above, and then we are going to multiply that back in. So 3x times x squared is 3x cubed. 3x times negative 3x would be negative 9x squared. And then 3x times 2 would get me 6x. Then I'm going to put them together. So Megan, what do I got to remember here when I put those together? I got to change the signs. I'm subtracting. So change it, change it, change it. 3x cubes cancel. This is a 9x squared. This is a minus 2x, and I can go ahead and bring down that plus 11 as well. And then we just do it again. So, Kara, what do I need to multiply x squared by to get 9x squared? 9. So she puts a 9 up here. And then she's multiplying down. 9 times x squared is 9x squared. 9 times negative 3x is negative 27x. And 9 times 2 is 18. Sam, I'm putting them together, so what do I got to make sure I do when I put them together? Flip the signs. Good. Change all those signs. My 9x squareds are going to cancel. This is going to get me 25x, and this is going to get me negative 7. What do I multiply x squared by to get 25x? Can't do it. This degree is bigger than this degree, so we're done. This is the remainder. So my answer is 3x plus 9, and if I were to write it in the proper form, it'd be 3x plus 9 plus 25x minus 7 all over x squared minus 3x plus 2. That's the remainder. We just took this and divided it by that. That's super ugly. And to be honest, today we don't really even care about that at all. We really don't care about the remainder again until we get into calculus second semester stuff. Okay, so you won't do that again until next year a little bit. But this is what actually matters. This 3x plus 9. And it seems so weird, like what did we just do? But it actually does something pretty cool for our graphs here. So let me show you what that looks like. Open. There we go. So I just had to talk to it. Somehow I changed the language to Italian when I click on that link. So that's super exciting, but it's fine. All right, so we click on that link. Here's that graph, 3x cubed plus 4x plus 11, x squared minus 3x plus 2. We have vertical asymptotes. We said vertical asymptotes at x is equal to 1 and x is equal to 2. Cool. Those definitely make sense. It definitely splits my graphs at those two lines. But then think about that other thing we got. We got 3x plus 9. 3x plus 9. That's that green line. Okay. Does it look like that green line applies to this graph? Yeah. Look at that thing. As I get really, really close to that line. Okay. They're almost the exact same line. The more I go to the left, the more those things look like the exact same line. We get an asymptote line here. It's not a vertical asymptote. It's not an oblique asymptote. It's a slanted line, and we talked about that on Friday quickly. Anybody remember what that was called? That is an oblique asymptote line. Okay, it's an oblique line. As I work to the left and to the right, I get really close to that line. I cross it right here. That's fine. You're allowed to cross it. It's what's happening to that graph as I go really far to the left and really far to the right. Okay, that's what I'm looking at more than anything else. Makes sense what an oblique asymptote looks like? Let's just stay on Desmos because I'm already here. But today we are talking about oblique asymptotes and horizontal asymptote lines. Okay, so look at this example right here. 1 over x minus 3. Definitely a vertical asymptote. We'd have a vertical asymptote at 3. Everybody agree with me on that one? Yeah. Is there a horizontal asymptote line? Y equals what do you think? At y equals 0, there's this split in my graph. I can cross it, but I don't. It's what happens as I work further and further to the right. That's what I care about. Okay. Oh, yeah, I'm getting really close to that line. As I go to the left, I get really close to that line. There is an oblique asymptote. Okay. What if I did this? Now, where do you think my oblique or my horizontal asymptote would be? At 1? Yep, right there. Okay. If I threw a 4 there. Okay, cool. Now my horizontal asymptote is at 4. I'm getting really close to that line as I go further and further that way. Makes sense visually what's going on there. What about this one? That line right there. Does that thing have a horizontal asymptote? No, because as I go to the right, it goes right down. As I go to the left, it goes straight up. It is no horizontal asymptote on that thing. Okay, there's a difference there. Okay, this one's a little bit strange. Let's do this one. Let's go sine. Let's go 4 sine x divided by x. What about this graph? Does it have a horizontal asymptote? Talk with your neighbor. What do you think? Horizontal asymptotes are what do you get as you get further and further to the left and to the right? Talk with your neighbor. Do you think that thing has a horizontal asymptote? All right, so we'll come back to this problem. Let's look at notes. On notes here, the top here, and this is the thing I'm trying to get to hammer home today. Okay, unlike vertical asymptotes, a function can cross a horizontal asymptote. You absolutely can cross a horizontal asymptote. Horizontal and oblique asymptotes. Those are the two new things we're doing today. It's more about the behavior of your graph as you approach positive and negative infinity. What does this graph look like the further to the left and to the right that I go? That's what a horizontal asymptote is. Okay, so if you look at this first example up here, as I go further and further to the right, I get closer and closer to that blue line. It looks like that blue line as I go further that way. That makes it a horizontal asymptote. Okay, same thing on this graph. As I go this way, I'm getting closer and closer to that dash line. As I go that way, I'm getting closer and closer to that dash line. That's a horizontal asymptote. What kind of asymptote does this third graph have? An oblique asymptote. We get this line right here. Okay, as I work out, if I were to continue to zoom out of that graph, you would notice that I get closer and closer to that thing. It looks like the line y equals 1/2 x plus 1. Okay, that's just the slope of that line with the plus 1. Cool, that would be the line. So that takes us back to this graph. What do we think? If I were to look at this graph and I were to zoom out more and more, as I go to the left and the right, does it look like I'm approaching the same number as I go left and right? What number am I getting closer and closer to as I go this way? 0. Okay, so this graph right here has a horizontal asymptote at y equals 0. Let's look at one more here. And this is, again, I'm just kind of freelancing here a little bit, but this is good stuff to think about. Look at this graph. Okay, this is 5. So look at the units here. On this line, it goes like 5 and 10 and so on. On this other graph, it goes 100, 150, 200. As I go further and further to the right, does it look like I'm approaching a single number? Yeah, what number am I getting closer and closer to? 3. I'm getting closer and closer to 3. I'm at 795. That number's not moving at all. As I go this way, What number am I getting closer and closer to? -3. So that graph has two horizontal asymptotes. Because one way I'm approaching 3, the other way I'm approaching -3. That's perfectly fine. You can do that. It's just what are you approaching as you work left to right? That's what we're looking at more than anything else. So, horizontal and oblique asymptotes. It's about what's happening to the graph as we go left and right. Okay? To find them, it's a little bit of memorization, but this is something you're going to use a ton. Okay? And if you think your way through it, it makes some sense as to what we're doing. Okay? What we're looking at, and I use the word exponent in my notes, and I wish I would have changed that. Think of degree, because we know what degree means. We're thinking about the degree of the numerator and the denominator. So when you read exponent in these notes, I need to update them. Let's change it to the word degree, because we know what that means. If the degree in your numerator is less than your denominator, then we have a horizontal asymptote at y equals 0. That is a thing. For example, looking at this first one, I've got 2 over x plus 7. What is the degree of your numerator? It's 0 because it's like x is 0. What's the degree of your denominator? 1. It's x to the first. So since the bottom is bigger than the top, since the degree on bottom is bigger than the top, I have a horizontal asymptote at y equals 0. Okay, horizontal asymptote at y equals 0. And this should make sense to us in terms of what we're doing. Horizontal asymptotes are what is happening as we go further and further to the right, as we approach infinity. So if I did 2 over infinity plus 7. So think if you had $2 and you were trying to divide it by infinity amount of people. We had $2 divided by 10 bajillion people. How many dollars is each person getting? Very close to 0. As I work to the right, I'm getting closer and closer to 0. Okay, same thing if I did negative infinity. I'm getting closer and closer to 0. So that is why you have a horizontal asymptote at 0, because you're dividing by a number that's way bigger than the number on top. The second thing, if your degrees are equal, then we look at leading coefficients. So for example, 2x over 4x minus 6, the degree on top is 1. The degree on bottom is 1. All right, cool. The degree on top and bottom are 1. They're the same. So we're going to have a horizontal asymptote at y equals the leading coefficients. On top, I've got a leading coefficient of 2. On bottom, I've got 4. What's 2 divided by 4? 1/2. 1/2. 2 divided by 4. Simplify that thing down. It's 1/2. Again, if I were to look at infinity, if I go -6, that -6 doesn't matter. If you have $10 bajillion, you lose $6, cool. I don't care. You can take $6 from me. It doesn't matter. Okay? But those infinities are going to cancel. They're going to leave you with just 2 fourths. Okay? That's what we're dealing with on the second one. So if degree is bigger on bottom, 0, equal leading coefficients. Then we get into the tough one. If your degree on top is bigger, then you're not going to have a horizontal asymptote. You're going to have one of other two options. You're either going to have an oblique asymptote or nothing at all. Okay? So remember, oblique just means a slanted line. Y equals mx plus b. If your degree in your numerator is 1 more than the denominator, then you have an oblique asymptote. Okay? So looking at this example, x squared plus 2x minus 4 all over x plus 1. What's the degree on top? 2. What's the degree on bottom? 1. It is 2 and 1. It is 1 greater on top than bottom. Then I'm going to have an oblique asymptote. I'm going to have an oblique asymptote. Then it comes down to the decision. Can I do long division or can I do synthetic division, or do I have to do long? In this case, I'm dividing by x plus 1. If I'm dividing by x plus 1, can I do synthetic division? Yeah, you can. And so we are going to do synthetic division. I'm dividing by x plus 1, so cool. I'm going to put -1 in the box. My leading coefficients are 1, 2, -4. And I'm going to do long division or synthetic division. Drop my 1, multiply, add, multiply. I don't care. The remainder does not matter here. Okay, what matters is this 1 and 1. I have an oblique asymptote here at y equals what? What does this 1, 1 mean? That is x plus 1. I have an oblique asymptote at x plus 1. I could do synthetic division there because of that setup. The 1 and 1 are there. I don't care about the remaining. Okay? If it wasn't x to the first power, then I cannot do synthetic. If it's x to something other than 1, like squared or cubed or anything else, I've got to do long division just like we did in Bell work. But in that case, do synthetic because we can. Okay? So 1 greater on top, we do synthetic division. Okay? Our last option. If our numerator degree is more than 1 greater than our denominator, then we do not have a horizontal or an oblique asymptote. Okay? If it's way bigger on top, then we have neither. So looking at this thing, x to the fourth, so the degree is 4. On bottom, the degree is 1. It's bigger on top by more than 1, and so we have no horizontal or oblique asymptote. Oh my goodness. No horizontal or oblique asymptote on that. Okay. Again, if I plugged in infinity, infinity to the 4th power divided by infinity. Infinity to the 4th power is enormous. It's the biggest number you could possibly fathom times 4 or to the 4th power. Okay. That is way bigger than on bottom. So that number on top is going to keep growing and growing and growing. It is not limited by anything. Okay. That's why we don't have a horizontal or oblique. Questions on how we set this up? Now we're just going to practice it. So flip it to the backside. I taught you everything you need. Now we're just going to practice what we just did, what we just said. So for each problem here on the backside, we're going to find vertical asymptotes, we're going to find horizontal, and then we're going to find oblique asymptotes. The option is either this or that or none. You cannot have both a horizontal and an oblique asymptote. That is not a possibility. Okay. Tomorrow we'll add in holes as well. Today I'm not throwing in holes at you. Okay. So just be aware of that. So first thing we're going to do is find the vertical asymptote. Show me with your fingers. Where's your vertical asymptote on number 1? On number 1, we take the bottom, set it equal to 0. I have a vertical asymptote at x is equal to 0. Done. Then we are going to look at degrees. Show me with your fingers. What is the degree of the numerator? Show me with your finger. What's the degree of the denominator? They're both 1. So if they're both 1, what is it? It's a horizontal asymptote. And what am I looking at? Leading coefficients. That is my leading coefficient on top. That is my leading coefficient on bottom. So it's a horizontal asymptote at y equals -1 over 1. The answer is -1. These problems are great if you have Desmos pulled up on your phone. Okay? Your graphing calculator is wonderful. Okay? The only reason why I tell you to use a graphing calculator is because on the SAT and the AP Calc exam, you cannot use Desmos. Otherwise, the only thing we would use in here is Desmos because it's significantly better and faster. Okay? And so I would strongly suggest to you that on your phone, you have downloaded the Desmos app. Okay? You could have it up on your note as you're doing your notes or your homework to quickly check stuff. Okay? So, for example, the problem we just did, we had -x minus 1 divided by x. All right, let's look at that graph and see what we just said was true. We said there was a horizontal asymptote at y equals -1. Oh, yeah, that makes sense. And there is definitely a vertical asymptote at 0. That's a quick way to check your work. Try number 2. Number 2, Kendall, what'd you do first? Mm-hmm. Good. X is equal to plus or minus 3 because if she were to plug in 3 or -3, you would get undefined. If you plug that on top, it won't change anything, so we're good. It's just plus or minus 3. Then we're doing horizontal asymptotes. So, Kate, as you look at the top, what's the degree on top going to be? It's 2 on top. What's the degree on bottom? 2. They're the same, so we're going to have a horizontal asymptote at y equals, what are you going to look at? We're going to look at the leading coefficients. So I'm looking at the leading coefficient. So it's 2 over 1. We're going to divide 2 over 1. So y equals 2. That is my horizontal asymptote. Again, if we were to look at the graph here, here is my graph. We have x is equal to 3. Yep. X is equal to -3. Yep. And y equals 2 for sure. Okay. It's definitely splitting up my graph and I can quickly see what's happening. Okay. Try 3 and 4 with your neighbor. See what you can do with those two. Find the vertical, horizontal, and oblique asymptotes. All right, let's look here a little bit so we don't get too far behind. On number 3, Jack, what do you do for vertical asymptotes? Yep, set the bottom equal to 0. Vertical asymptote at x is equal to 1. It's a vertical line, so it's x equals. Great. Then we're looking at horizontal or oblique. So to find that, we're looking at degrees. We're looking at that. Annika, what did you say was the degree on top? 0. Degree on bottom? 1. So if it's bigger on bottom, then where is my horizontal asymptote going to be? At y equals 0. It is bigger on bottom, so the bottom's going to keep growing. We get closer and closer to 0. On number 4, we're finding those things. Okay, so Herman, how'd you find vertical asymptotes there on number 4? Good. So she factored there. She factored into x and x plus 4. So you have vertical asymptotes at x is equal to 0 and where else? -4. Lovely. She's got her vertical asymptotes just like we should. Next thing we're doing is we're looking at degrees. So if we're looking at degrees here, Aaron H., what's the degree on top? 3. What's the degree on bottom? 2. So what kind of asymptote am I going to have here? I've got oblique here because the top is 3 and the bottom is 2. The top is greater by 1, so then I've got oblique. Okay? Can I do synthetic division here? No, because the thing I'm dividing by is x squared. If I'm dividing by x squared, I cannot do synthetic. So we have to do long division. Yucky, but we can do it. X squared plus 4x goes on the outside. 4x cubed plus x squared minus 2x plus 4 goes on the inside. Then we are doing long division. So we ask ourselves the question, x squared times what, Sam K, is going to get me 4x cubed? 4x. So she puts 4x up above. Then we're multiplying down. 4x times x squared is 4x cubed. 4x times 4x is 16x squared. And then Sam M, what do I got to do next? Flip my signs. Change the signs. That cancels. This is minus 15x squared minus 2x and then a plus 4. And then we really only have one step left. Sophia, what do I got to multiply x squared by to get negative 15x squared? Negative 15. And I'm done. I don't care about the remainder at all here. This is an oblique asymptote. This is my answer. It's in the form y equals mx plus b. So I have an oblique asymptote at y equals 4x minus 15. Once you've got it in that form, you can be done. Okay, if you want to keep doing it, great. But I'm not going to because it seems silly to do it when you already have your answer. Okay, I'm pulling it over. There we go. There's the graph of what we just looked at. Okay, we found vertical asymptotes at x is equal to 0 and x is equal to -4. Those totally make sense. And then we have a oblique asymptote at y equals 4x minus 15. As I zoom out, yes, especially as I zoom out, I get closer and closer to those lines like I thought I was going to. Again, having decimals out on your phone would be a quick way for you to check to make sure that your picture makes sense. Try 5 and 6 with your neighbor. Go. On number 5, Ella, how'd you find vertical asymptotes? Good. Vertical asymptote at x is equal to 3. Then Aaron Cardinal, what's the degree on top? 2. What's the degree on bottom? 1. So what kind of asymptote am I going to have here? Oblique asymptote. It is 1 greater on top. So again, I'm going to have an oblique asymptote on this one. Can I do synthetic division on this problem? Yes, I can. Because I'm just dividing by x minus 3, just do synthetic. It's way easier. Okay, if you want to do long division, go for it. But it's just going to, it's not, neither of them are hard. It's just way faster, I would say, more than anything else. Drop the 3, multiply, add, multiply. I don't care. This is what I care about, the 3 and the 7. Okay, oblique asymptote at y equals what here? Yep, done. That's my answer. Number 6, Eli, what's your vertical asymptote going to be? At x is equal to 1, because all he's got to do is take the bottom, set it equal to 0. Evan, we're doing horizontal or oblique. What's the degree on top? 5. What's the degree on bottom? 1. So it's bigger on top than bottom. what kind of asymptote am I going to have here? Is it 1 greater on top than bottom? No, it's 5 over 1. So if it's more than 1, then the answer is there's no horizontal or oblique asymptote. I got neither there. If the top is greater than the bottom by more than 1, no horizontal or oblique asymptote. Questions on 6? Let's just keep running through this thing because there's no sense in stopping. Haley, what'd you do to find vertical asymptotes on 7?
I factored the bottom to x minus 3.
X plus 2, x minus 3. So vertical asymptote at x is equal to?
X equals negative 2 and x equals 2.
Wonderful. Then we're doing horizontal or oblique. Abby, what's the degree on top?
Yeah.
Degree on bottom? 2. So it is bigger on bottom. So if it's bigger on bottom, where's my horizontal asymptote going to be? At y equals 0. The bottom is going to continue to grow and grow and grow. It's y equals 0. Good. Number 8, we're looking at that one. We're finding degrees on top and bottom. So on number 8 here, Herman, we set the bottom equal to 0. What'd you get for that? Yep, good. Sorry. X equals negative 4 on bottom. Then we're looking at degrees. Everybody show me with your fingers. What is the horizontal asymptote going to be for number 8? Horizontal asymptote on number 8. What is true about the degree on top and bottom? They're the same. So you guys are showing me that my leading coefficients are going to get me my answer. Horizontal asymptote at y equals negative 1/4. Ugly, but fine.